Hello everyone, today in this video we'll be discussing the third module of maths, and in this module we have mainly two topics and it's very easy module. The first one is random variables and the second one is functions. Okay, so in the first part we'll be learning what is discrete and continuous, and then we'll be learning two applications of discrete and two applications of continuous, which is binomial and Poisson and exponential and normal distribution. Okay, so let's get started. The first one under random variables is discrete. Discrete means distinct values. You have to remember these five formulas here. The question will be as follows. Okay, we'll be discussing an example also. So the x values will be given here, and those probabilities will also be given here. Okay. So what you have to do, you have to remember these five formulas. P of xi means each probability. Okay, it should be greater than or equal to 0. The second one is the probability of the each of these sum will be equal to 1. All the probabilities sum will be equal to 1. Okay, and third one is each probability should lie between 0 and 1, not greater than 1, not lesser than 0. Okay, and the fourth one is mean. How to find the mean? Multiply these two and multiply these two and so on, and add all of these. Okay, that will give us the mean. And variance is defined as sigma square, which is standard deviation square. That's the summation of xi square into p of xi. Xi square means find out its square, multiply with this, find out this square, multiply with this, and so on till the end, and then add each of these terms. Okay, that's the this term. Okay, minus mean square, find out the mean, square it and subtract from this. That will give us the variance. Okay, let's solve a problem. This is the question. X values are from 0 to 7, and the probabilities are from 0 to 7k square plus k. I've tried to include all the possible questions which can come. Okay, so let's solve each of these one by one. Firstly, they can ask you to find out the value of k. Here you can see the k terms also. So what we'll do is we'll use the first formula here, which is the second formula, which is the summation of all the probabilities should be equal to 1. So we'll add all of these probabilities here. That should be equal to 1. Therefore, I'll write 0 plus k plus 2k till 7k square plus k, that is equal to 1. I'll get a quadratic equation, and by using that I'll find out the value of k. K, two answers you will get, 1 by 10 and minus 1. This cannot be possible because all the values should lie between 0 and 1. Therefore, the k's value is 0.1. Okay. After getting the k value, I'll substitute the k value here and find out the original probabilities. Okay. So these are the probabilities here after multiplying with k, and by using this we can find out the next one, which is mean. Okay, e of x is also called as mean. Okay, to find out the mean, we'll multiply x with p of x. What is this? Multiply 0 with 0 plus 1 into 0.1 plus 2 into 0.2 plus 3 into 0.2, like that till 7 into 0.17. Add all of those terms, you'll get the mean. Okay, in the same way, how to find the variance? X square into p of x. Okay, first we have to find out this term, then subtract with mean square. Mean is this one. Okay, first we'll find out this term. How to find out that? That will be 0 square into 0. Okay, and 1 square into 0.1, 2 square into 0.2, like that till 7 square into 0.17. Add all of those terms, you'll get the answer here. Subtract that answer with the mean square. Okay, that will give us the variance. If you have to find out the standard deviation, find out the root of the variance, you'll get the standard deviation. Then probability of x is less than 6. That means p of x is equal to 0 plus x is equal to 1 till x is equal to 5. Okay, these probabilities you have to add. 0 plus 0.1 plus 0.2 till 0.5. Okay, so after adding all of that, you'll get the answer here. Or you can do in the other way also. 1 minus, see, total sum is 1, right? Total sum is 1. We have to find out these probabilities. Subtract from 1 these two probabilities, you'll get the answer in that way also. Okay, so both ways you can use. And the second one is p of x greater than or equal to 6. That means p of x is equal to 6 plus p of x is equal to 7. That you'll get the answer here. Or you can subtract 1 from 0.81 also. Okay, the next one is continuous, and it's more easier than the previous one, because in this formula we'll be using the integration and we need not do much calculation here. Okay, see here the same formulas are used here. Every probability should be greater than 0, and the sum of all the probabilities should be equal to 1, and here we'll be having the probabilities from the minus infinity to infinity. Okay, and mean will be x into f of x, and variance is x square f of x minus mean square, the same formulas as the previous one. And if you have to find out the probability between like 1 less than x less than 2, at that time we'll be using this formula. Limits will be from a to b. Okay, so let's see a problem here. Find out the constant k such that f of x is defined as two terms. When it's between 0 and 3, it is kx square, else it's 0. Okay, so the timeline will be as follows: from minus infinity to 0 it will be 0, and from 3 to infinity it will be 0. Only between this interval it will be kx square. Okay, so what we have to find out: the probability of 1 less than x less than 2. But before that we have to find out k. Okay, to find out k we can use the first formula, which is the second formula, which is the summation of all probability should be equal to 1. Okay, so we can write the summation here by using integration f of x from minus infinity to infinity. Since these both are 0, we'll be just considering we'll be just looking at this interval, writing that interval here in the terms of limit, and then writing f of x value, which is kx square. We'll get the answer of k as 1 by 9. Okay, after getting the value of k, we will be finding out the first one, which is probability of x between 1 and 2. Okay, find out that we'll be writing the limits 1 and 2. The value of f of x is kx square. We know the value of k here, and finding out the integration and applying the limits, you'll get the answer here. In the same way, we'll do for x is less than 1 also. X is less than 1 means minus infinity to 1, but minus infinity to 0 it is 0. So we'll be just considering 0 to 1. Okay, apply the limits and find out the answer. What about x is greater than 1? That means from 1 to infinity. Okay, but 3 to infinity is already 0, so we'll just consider 1 to 3. Okay, we can also do that by considering the integral from 1 to 3, or what we can do is the total probability is 1. 1 minus, already we have found out less than 1. So to find out greater than 1, we can subtract 1 from less than 1. Okay, that also gives the same answer. Next, to find out mean, we'll be just writing here x. Will not be multiplying anything as in the previous case, but we'll be writing here x into f of x. F of x is kx square, right? Kx square into x is kx cube. So we'll be finding out the integration for kx cube, and then applying the limits to find out the final answer. Okay, in the same way, variance also, we'll finding out x square into f of x, which will give us kx4 minus mean square. Mean is here, find out the square and subtract from this. That will give us the final answer. Part of the module, in this module we'll be applying these two, which we learned in the previous topic about discrete and continuous in binomial and Poisson. Okay, so let's start with the first one. So in binomial, you have to remember the 5 formulas. These 5 formulas: p of x will be always greater than or equal to 0, and p plus q is equal to 1. P means probability of pass and q means probability of failure. That both sum should be 1. Okay, and this is the main formula which you must remember, which is p of x is equal to ncx p power x q power n minus x. Okay, this is the main formula, and all the summation of probability is 1. And these formulas: mean is equal to np. N is the number of objects considered, and variance is sigma square, which is npq, and standard deviation is the square root of this. Okay, square root of npq. Now let's see a problem here. The probability that a pen manufactured by a company is company will be defective is the probability that a pen manufactured by a company will be defective is 0.1. So what we have to first we have to select what is p. Okay, read out the sub questions. What we have to find out: exactly 2 pens will be defective. That means being defective will be p. Okay, p means success. Rate of success means how much will be defective. Okay, in our case it is 0.1, so probability of p is 0.1. Then after getting the number of p, we will be finding out the n is 12 such pens. And what we have to find out is this formula. What we have to find out is exactly 2 pens will be defective. We know p is 0.1, therefore q is 1 minus p, which is 0.9, and n is 12. After getting the 3 values, you can proceed. Okay, write the formula, which is ncx p power x q power n minus x. Okay, after writing the formula, first we have to find out exactly 2 pens will be defective. So 2 pens are there, so x value is 2. We have to find out p of x is equal to 2. So in the place of x, substitute 2 and find out the answer. Okay, in the same way, the second one is at most 2 pens will be defective. At most means not exceeding 2. That means less than or equal to 2. So less than or equal to 2 means p of 0 plus p of 1 plus p of 2. Substitute in each of these x values as 0, then 1, then 2, and add these values to get the final answer. And the third question is none will be defective. None will be defective means p of x is equal to 0. Okay, substitute the value of x as 0 here and get the final answer. This was for the binomial. Let's discuss about Poisson. These two main formulas you have to remember. P of x is equal to e power minus m power x divided by x factorial, and m is equal to np. Okay, let's see a problem here. In this we have been given, if the probability of a bad reaction from a certain injection is 0.001, determine the probability that out of 2000 individuals more than 2 will get a bad reaction. So what we have to extract from the question, see here. So what we have to extract from the question, first write the main formula, e power minus m power x divided by x factorial. N is how many individuals? 2000. So n will be 2000, and the probability which they have given is 0.001. So p will be 0.001. And what is m? We have to find out that. It's np. N and p we have, multiply it, we'll get m. After getting m, substitute that here, m. Then we'll find out what they have asked for. They have asked for more than 2. More than 2 means greater than 2. Greater than 2 means 1 minus p of x is less than or equal to 2. This we will expand here. That means p of 0 plus p of 1 plus p of 2, and substituting the value of x as 0 here and 1 here and 2 here, m we have already found out, and calculating the answer, we'll get the final answer here. Okay, we have done the first part, which is binomial and Poisson. Let's move on to the second one, continuous. The first one is exponential. Let's see how it is. In exponential distribution, you have to remember these four formulas. We will find f of x. When f is positive, it will be this value, else it will be 0. And the mean is 1 by lambda, and variance is sigma square, which is 1 by lambda square. Okay, and summation of all probabilities will be equal to 1. Okay, let's see a problem here. In this we have been given that the average is 200 months for a life of a compressor which follows exponential distribution. Find the probability that the compressor will have a life of less than 200 months and between 9 to 25 years. Okay, convert the years into months, we'll get 108 and 300. Okay, and now what we have to find out, first see what they have given. Average is given, which is mean, so nu is given to us, and we have to find out the probability of a compressor having life. So in our case, x will be a compressor having a life. Okay, so here it will be x is life of a compressor in months. Then average is given to us 200 months. Okay, so we'll be noting down that, and by using the formula, mean is equal to 1 by lambda, we'll find out the value of lambda. Nu is equal to 200 is equal to 1 by lambda, so lambda will be 1 by 200. After getting lambda, we'll be applying this formula for finding out the particular values of x. Okay, if it is positive, it will be this, or otherwise it will be 0. Okay, lambda e power minus lambda x. Okay, so in the first case, what we have been given is to find out the life of compressor, probability of having a life less than 200 months. That means p of x less than 200. So the limits will be from 0 to 200, and this will be f of x. What is f of x? E power lambda e power minus lambda x. Lambda is a constant we can take out, and applying the value of lambda here or at the final stage is the same thing. Okay, apply the value of lambda which you got 1 by 200, and after getting that, after applying the value, you'll get the final answer here, probability of life less than 200 months. Similarly, in the second question we have been asked probability of life between 108 and 300 months. It's simple, just apply the limits as 108 and 300 here, and apply the value of f of x. Okay, same thing, you'll get the final answer here. Okay, we have discussed the first one, which is exponential. Let's move on to the normal distribution. In normal distribution, remember two things, x is the normal variate and z is the standard normal variate. Okay, so these are the formulas for f of x, and two formulas which are mostly used are this one and this one. Okay, so I'll be discussing each of these step by step. Okay, I'll be solving two types of problems. First one is basic problems to give an idea of what the thing is, means how to apply the formulas, and then we'll be solving the exam based questions. Okay, so let's move on. Firstly, remember here, these are all the probabilities from minus infinity to infinity. So the whole area will be 1, and it's divided into two parts. From minus infinity to 0, it will be 0.5, and from 0 to infinity it will be 0.5. So this area is 0.5 and this area is 0.5. Now let's move on to the questions. You will be given with a values. I'll be discussing what it is, and the first question is to find out the probability of z greater than 1.85. Let's see how it looks in diagram. Probability of z greater than 1.85 means z's value, which is 1.85 here, greater than that means this area till infinity. Okay, we have to find out the area of this. How can we find out? We know one thing, which is from here till infinity it is 0.5 total. Okay, this all area is 0.5. Now if we subtract this area from 0.5, will be remaining with this area. How can we get this area? This area is given by A of Z. What is Z value? 1.85. So A of Z means area till 1.85, means A of 1.85 means area till 1.85, which means this area. If we subtract this area from 0.5, this total is 0.5. Okay, from here till infinity it is 0.5 minus A of Z minus this area will be remaining with this area. So that's what we are doing here. 0.5, which is this whole area, minus A of 1.85, this area. So we'll get this area. Okay, so in the second question, P of Z greater than minus 1.85. Where is minus 1.85? It's here. Okay, so which area we have to find out? Greater than this part. Okay, means all this area we have to find out. Now one thing we know that this part whole area is 0.5, so we are just concerned about this area. Okay, this area is also total 1.85, total 0.5. So what we have to do is we have to find out only this area. That means we have to subtract this area from, see, we have to subtract this area from 0.5. Okay, if we subtract this area from 0.5, we'll be remaining with this one, and then we'll add that with 0.5 to get the final answer. How can we get this area? This area is nothing but it's symmetric, right? So you can take this on the opposite side also. So it will be like this. See here, 1.85. This area is equal to this area. From z is equal to 0 to 1.85. What is this area? This area is the area of z from 0 to 1.85. That is A of z, which is A of 1.85. By using A of 1.85, we can find out this area. This area we can substitute here. A of 1.85, this one, and we'll add with 0.5. So that's what we are doing here, 0.5 plus A of 1.85. Okay, that will give us the final answer. These two values of A are given here in the question. Okay, by using these two values we'll be finding out the questions which are asked in exam. Okay, now see, the third question is z less than minus 1.85. Minus 1.5, mark it in the graph here, and less than that means this area. How can we find out this area? We know this one, it is 0.5 minus this area. This area is A of z. A of z, 0.5 minus A of z will give us this area. Okay, similarly the fourth one is z less than 1.85. 1.85 is here, less than that means this area. You can find out this area by 0.5 plus A of z. Okay, and the fifth one is between 2 points, 1.85 and 1.98. Till this one it is A of 1.98, area till 1.98. We need just this area, so we'll subtract area from 0 to 1.85 minus area from 0 to 1.85. That will be given by A of 1.85. When you subtract this, we'll be remaining with this area. Okay, in the same way these questions are there, like minus 1.98 to minus 1.85. This is the limit. And how can we find out this? This total is from here to here, it is A of, if we take the symmetry of it, what we'll get is the same one as the previous one. See, 1.98 means this one, 1.85 means this one. This we have to find out. From here till here it is A of 1.98, and we have to subtract this one. This is nothing but A of 1.85. When you subtract this, we'll get the answer of this area. Okay, the same as the previous question. And lastly, the area from minus 1.98 to 1.85, that means this whole area. How can you find out that? From here to here it is A of 1.98, from here to here it is A of 1.85. Adding both will give us this total area. Okay, now let's see the type of questions which are asked in exam. So the question will be of this type. In a test on 2000 electric bulbs, that means N, is it was found out that the life of a particular make was normally distributed. See, they have given normally distributed, that means X. Okay, remember that, with an average life of 2040 hours, which is new, and a standard deviation of 60 hours, which means sigma is 60. Estimate the number of bulbs likely to burn for three cases they have given: more than 2150 hours, less than 1950 hours, and between 1920 and 2160 hours. Converting that in the form of X, what we'll get is probability of bulbs X, which is greater than 2150, greater than 1950, and between 1920 and 2160. Okay, since they have given normally distributed, we'll be considering X here, else we'll write there Z. Now to find out the answer, we need the formula in the terms of Z. For that, what we can do is we can use this formula. This formula converts X into Z. Okay, We have been given with the mean and the average, mean and the sigma. So by using that, we can convert the value of x into z. Let's do that. We have to find out the life of the bulb in hours. Therefore, we will write x, and n is 2000, mean is 2040, and sigma is 60. And these values, they have been given in the question paper. And by using this formula, we will be substituting the value of x here. Initially, the x value is greater than 2150. So what we will be doing is, we will be writing here instead of x z, and then instead of 2150, we will be writing x minus 2040 by 60. This one will be writing here and substituting the value of x as 2150 here. Okay, so this is nothing but x minus 2040 by 60, and x is given as 2150, so we'll be writing here 2150. So what we'll get is 2150 minus 2040 by 60. That's the same as here, 2150 minus 2040 by 60. Calculating this answer, we'll get as 1.83. Therefore, what we have is p of z greater than 1.83. Now, how to find out probability of x greater than z greater than 1.83? In graph, it will be this point, 1.83 and greater than 1.83. How we can find out that? 0.5, this total is 0.5 minus a of 1.83. That's what we are doing here, 0.5 minus a of 1.83. Okay, then the next question is, and before that, they have been given that number of bulbs likely to burn for more than 2150 hours. The total number of bulbs are 2000, so multiplied by the probability which you got here, that will give us approximately 67 bulbs. Similarly, proceeding to the second question, less than 1950 hours, we will be writing the same thing here. P of x less than 1950, write in x instead of x, write here z, and then 1950 substitute in the value of z. We'll get 1950 minus 2040 by 60. Finding out, we get minus 1.5, which is this point here. You have to find out z less than minus 1.85, which means this point, this area. That will be 0.5 minus a of 1.5. Okay, 0.5 minus a of 1.5 will give me this answer, this area. Okay, so that I will be getting 0.0668. Okay, and finally I will be multiplying the probability with the total number of bulbs. Okay, and lastly, we have to find out the probability of minimum between 1920 and 2160. So we'll be writing here in between z, 1920 and 2160 formula, and in between z, so we'll get minus 2 to 2, so that's nothing but minus 2 here and 2 here, so it's nothing but a of z plus a of z. Here also it is a of z only if you take the symmetry, so it is 2 times a of z. Z is 2 here, so it will be 2 times a of 2, which is 0.9544. Finally, multiply the value with 2000 bulbs, so you'll get the approximate number of bulbs having life between 1920 and 2160 hours. Okay.